of those features here. One feature that stands out is that this server is responsive, or that means, what does responsive means? It is a scalable server. So if the user is either using a computer as desktop or using a smartphone or a tablet, it will have the support for all these platforms. So if he's using a desktop, if the user accesses the port 8083, the layout is going to be this one. And if the user is using a desktop, so the port number, a smartphone, and then the port number should be 8084, and then it's going to pop up this web page in the cell phone. That means that the user does not has to keep zooming in and zooming out to get every information. It's already here scalable. And even, as I already said, if the user has a tablet, it can access the port 8085 and everything is going to be exactly really in a really good size. Also, another thing that stands out when we're talking about this FHEM is that this web server supports a lot of different protocols as JSON, XML, HTTP, TCP, IP, and in our case we chose to work with MQTT. But why did we choose MQTT? When we are talking about IoT projects, MQTT is highly recommended and broadly used by many developers. And this MQTT stands for Message Queue Telemetry Transport. But why? Why again MQTT? Well, it brings with itself a lightweightness. That means that the message is not really huge, it's not big, it's not a heavy message. It's like really light and it can be transported without many efforts. It also has the publish-subscribe model, the model that my friend will have the pleasure to present you.
This publish-subscribe model contains three main elements: the publisher, the subscriber, and the broker. The publisher is the device that has the intention of posting the information online. On the other hand, we'll have the subscriber, the one that signs up to a desired topic with the intention of receiving this collected data. Lastly but not least, comes up the broker, the one that is responsible to establish the correct link between those two, the publisher and the subscriber. Standing out that this connection, this transfer of data, is done solely and exclusively by the broker. That means the publisher does not have the knowledge about the subscriber existence and vice versa. The only need for those buff extreme parts is the IP address of the broker and the port number. And also concerning the MQTT protocol, this protocol uses a way to better organize the message. What do I mean with this? The way that this protocol used to better organize the message is to split the message up into topics, and each topic contains a specific subject matter. So, the publisher will publish the message in a specific topic, and if the subscriber wants to receive this collected data, it's necessary to sign up in this specific topic. We have also two more features that stands out. The first one concerning its speed. So here, fast. The MQTT protocol is roughly 93 times faster than the HTTPs, for example. And another feature concerning its delivery is the so-called QoS, that stands for Quality of Services. To better explain how this QoS feature works, we did a table to illustrate a bit more. We have three levels of QoS: 0, 1, and 2. Well, if we are talking about the QoS equal to 0, the message will be delivered at most once. So for this, we have the best effort concerning the delivery. However, we have no guarantees that the message will be delivered. Then we have the QoS equal to 1. In this case, the message will be delivered at least once. So now the time is going to increase a bit. So we are sure that the message will be delivered. But for this, as we are, will be necessary some acknowledged messages, the time is going to be a bit longer. So, and also we have the possibility that this message will be duplicated. And if you have the QoS equal to 2, the message will be delivered exactly once. So now we have 4 acknowledged messages. So now we are really sure that the message will be delivered because of the acknowledged message. The time, of course, is going to be greater. And now we are not going to duplicate the message. And as I told you before, it's a bit logic, but as the QoS level increases, the time is going to increase as well. Now we are going to show you the simulation, the MQTT protocol properly working. So, as Murilo said before, a brief introduction concerning the broker, we chose the Mosquito as a broker. Eclipse Mosquito. Then, the subscriber, the publisher, is the DHT22 sensor that is acting as a publisher. So here, if we go to the source code, it's possible to see 2 specific topics. The first one concerning the temperature, as we are using the DHT22 that allows to get the information of the temperature and also the humidity. And sorry, we forgot to say about the range. The range for the DHT sensor is from between -40 and 80. And the humidity from 0 to 100%. So here we have 2 specific topics. The first one concerning the temperature and the second one concerning the humidity. And if we move to the FHN web server, it's possible to see here in the attributes that this web server is acting as a subscriber. So here we can see that it's already subscribed at the same topic that I just shown you. So as expected, now we can see the measured values of the temperature and the humidity in real time.
But what else can we do with such information? Here, if we scroll down, we can see that here we have the SVG plot. It's a graphic that shows in real time the modifications on the temperature and on the humidity. And not only this graphic, but also we have the feature of creating like a background of everything that happened in the environment. This is a historic of the temperature that you're measuring, and it's going to be saved in the computer, as I'm going to press it now. So here, there is a log file. As you can see here, this log file. And if you open this log file, you can see that it's exactly now, the last measurement is exactly this time right now. And you can compare this log file with the event monitor that also has to print the same information, because you're saving the information of the current status of the environment. So that brings us to the end of our presentation. And to summarize everything that we have discussed during this presentation, there's nothing better than a table. And that's what we built. So here in this table on the top we have the 4 different web servers that we use, and here we have the things that we are comparing: the interface, the extra feature, the cost, the web server setup, and also for those whom this web server are more indicated. So let's start with the interface. In the Python Anywhere, as we have seen, is a really simple interface, just black and white, nothing special, line by line. Finger.io has a complete dashboard with a lot of interesting things, and you can see where is your device located in the map and so on. ThinkSpeak is really simple, it's basic, it doesn't have much, but brings with itself the graphic. This is really good. And FAGM is scalable, it doesn't matter what kind of device you're using, it has the support for this device, and you can also change the background colors of the website as you wish, so it's really nice. Then let me talk about a little bit more of the extra feature that each one present. Python Anywhere, it, as I said, is simple, it has no extra features at all. ThinkSpeak, it has the map location, you can deal with many devices, not only one. The ThinkSpeak, you can create a channel, you can add more than one measurement in the same channel, and you can display the information with a graphic. That's something that's really good for those users that wants to follow the modifications. And FAGM, so far so good, has the SVG plot and also the log file that saves the information in offline historic in your computer. Talking about the costs of each of them, those true ones depends on the plan. Python Anywhere for beginners, it's free, but just for a short period of time. Finger.io, it's free, is limited free, but you can only have up to 2 devices. If you want to add more devices, then you have to pay. ThinkSpeak again is the same thing as Python Anywhere, is free until some date, then you have to pay it or create a new account. And FAGM, it's completely free, you don't have to pay, and is a huge community with a really good forum for those who has questions and want to solve other kinds of problems. FAGM is really indicated because it's not only free but also has a really good support of the community. And now talking about for those whom is better, they are more indicated, those web servers are more indicated. Python, not only Python Anywhere but also ThinkSpeak are only for monitoring. They cannot change the environment, the behavior of the environment. And on the other hand, we have Finger.io, and again the incredible FAGM that has the feature of also changing the behavior of the environment. In other words, sending back the information from the web server to the node MCU. That's the feature that FAGM and Think.io also present.
Well, we would like to leave you with the following thought. Smart devices are taking over and making every aspect of our lives easier. The implementation of the temperature management systems can provide countless benefits, including cost savings and more accessibility for the physically disabled and elderly user. In this way, changing lives.
So if you have any question, it would be a pleasure to solve those questions right now. And don't forget, you can find us at our emails. It was a pleasure to be here today. Thank you so much.
It was a pleasure. Thank you.
29.